Today we're going to talk about heat and temperature. Heat is defined as the energy transfer between objects. For example, if I have two objects, let's call them A and B. And they are in contact with one another. Heat will always flow from a hotter object to a colder object. Heat will always flow that way. Heat is a form of energy, and energy we know is labeled in joules. So we will always refer to heat as Q, and Q is always going to be measured in joules. Now, if A is hotter than B, or if it has a warmer temperature, has more energy, heat will flow from A to B. So we would say that A is losing heat, so it would have a negative value. B is gaining heat, so it would have a positive value. But they will transfer heat until they are both equal. This is called thermal equilibrium. Now, if I were to add a third object to this, let's call it C. Since C is touching B, it will also become equal in temperature with B. It will reach thermal equilibrium. We can then say that C equals A's temperature. These also will equal one another. So, heat is talking about the energy between two or more objects. We can then talk about temperature. And temperature is actually how hot or cold an object is compared to a reference point. We take the temperature of an object with a thermometer or with some sort of measuring device. And how do we decide how to label it? Well, we have a couple different temperature scales. One scale is in Celsius. We would label it degrees Celsius. A common one that we use is degrees Fahrenheit. And one that we will commonly use in physics is Kelvin. Notice that there's no degree sign before Kelvin. It's just Kelvin. Now, you'll also be asked periodically to convert from one form to another, from Celsius to Fahrenheit. And to do that, Celsius temperature is equal to 5/9 times I'm sorry. To get to temperature in Celsius, I would do 5/9 times my Fahrenheit minus 32. Remember that do the parentheses first. So you take your Fahrenheit minus 32 and then multiply it by 5/9. To get to Fahrenheit, temperature in Fahrenheit is equal to 9/5 times the Celsius temperature plus 32. And finally, to get to Kelvin, Kelvin is equal to your Celsius temperature plus 273. The Celsius scale is based on the boiling and freezing points of water. Freezing point of water being at 0 degrees Celsius and the boiling point being at 100 degrees Celsius. This was kind of interesting. It's, in your book on page 316, we do know that temperature does not appear to have an upper limit. We know that the sun has a temperature of 1.5 times 10 to the 7th degrees Celsius. That's pretty hot. We don't know of an upper boundary, but we do know that there is a lower limit. And there is a lower limit because when heat is being extracted from an object, particles move slower and slower. And there gets to a point where they cannot move any slower. And we call that absolute zero. And absolute zero is on the Kelvin scale, which would be 0 Kelvin. It's impossible to reach a temperature any further than that. The example in the book was that if we were to take helium and cool it, it will contract in a way So that occupies a volume that is only the size of the helium atoms, which is at negative 273.15 degrees Celsius. So that's where the absolute zero comes from.